So we're going to first talk about our field evaluations real quick and go over the feature set that we needed for situational awareness, talk about some customizations that we did, the impact of surface metering, our design principles in creating the RTC, some of the challenges of the tool, and some features that controllers wanted that we didn't get to. So first, for the field evaluations, the point of this is that you have to get the tool in front of the users and actually using it. We spent a lot of time before this went to the field with PowerPoint presentations. We had 10 human-in-the-loop simulations, but once we got to the field, they had all kinds of new comments. Even the same controllers that had been in our human-in-the-loop simulations, they had been there for all 10 simulations. Once they got to the field and were actually using it in the field, they say, hey, well, we need this feature and that feature. And we were like, well, why didn't you tell us that before in the 10 previous simulations? And they said, well, that wasn't real life. And so it's important that you put the tool in front of the users and have them use it, because they will definitely have more comments. So in going to the users, so this is based primarily on Charlotte. So this is the entire feature set that the controllers felt that they needed for situational awareness to make them make the tool fully usable. And so I'm just going to blow through these because this is largely redundant of what Debbie just spoke of in detail. And so we just remind you that these slides are going to be posted online, and we ask you to just come back and look at it later. So these are the categories of all the necessary features that the controllers needed for situational awareness. And so Debbie showed you the overview of the RTC display. So these are the data elements for an arrival tag, certain data elements for a departure tag. The controllers needed to know the various flight states. So we have one set of flight states for departures and another set for arrivals. The controllers needed to be able to tell what large aircraft, B-757 and heavy aircraft, it was important for them to be able to distinguish the difference between those because they require more space around them. The controllers also needed to have another place to go look and see additional flight data if they needed more detail beyond what we could show on the tags that I showed you originally. The controllers needed flags for knowing when to expedite flights. So we have a category of emergency flights, priority flights, the arrival flight A0, A5, A14, and long on boards that Debbie discussed of the various time ranges. You know, these are flights that controllers needed to expedite, and so these are the alerts that we had. And then another one, which Debbie described in detail, was the gate conflicts and the ability to know when there's a gate conflict, because the controller would either need to expedite the departure or manage the arrival to handle that. Debbie talked in great detail about the TMI alerts, and so we use it by the reverse highlight of the various TMI fields to show if there's a TMI that affects the flight. And another feature that the controllers needed for situational awareness was being able to create a target. If it wasn't in the system, they needed to be able to create the flight target and create an aircraft target, where the difference between flight is that's a particular logical leg of a flight. You know, I'm going from Charlotte to LaGuardia or Dallas to Charlotte or whatever, whereas the aircraft is the actual physical piece of metal that does not necessarily have a flight associated with it at this particular time. And then another piece of it was being able to manage the strip or the icon. If you need to reposition a flight to the hangar or a hard stand or cargo area, or moving a flight from the maintenance area to the gate, or removing the target altogether, these were additional features that the controllers needed to keep their displays up to date. But the controllers did not want to see general aviation or cargo flights in their ramp map because it was just a distraction and clutter to them. They wanted those hidden, so they only wanted to see the general aviation or cargo flights if it was actually taxiing on the taxiways or in the flight runway coupe. Oops. that one. A particular feature that the controllers needed was being able to position the flight to orient them to where the flight would be. And so by default on the left there, the engine icon, when you push a flight back from the gate, by default the strip just displays a little bit distant from the gate. But so the controllers would like to position the tag where the flight would be when it actually completes its pushback maneuver, and they would orient the engine icon to be the nose of the flight to show them where the flight would be when it was done. And similarly, the hollow icons, which are the icons before a flight gets track data, the controllers are allowed to position that, rotate it, drag it to wherever they think the flight is going to be, so that improves their situational awareness. Some intent reminders. Debbie discussed in detail about the flights put on hold and the hard stand. These communicate intent between, it's not just a reminder for this controller, but if a controller's at another station, he can see that whether or not if a plane is going to be coming into his area or if it's going to be held off because it's got the red border. He can tell that immediately at a glance. And then the scratch pad here on the right, this is an area where controllers can write information specific to a flight to communicate information between controllers at different stations. Another feature of our map is that the gate numbers themselves can be color-coded to communicate gate status, owned, incoming arrival, if it's got a gate conflict, if it requires special handling, or if the gate is closed. We also have several features to communicate the airport status. We have the airport configuration in the toolbar. Debbie discussed our metering icons, and this is whether or not the ramp is open or closed. These directions communicate flow direction, our arrivals landing or taking off. North flow or south flow, I'm sorry, I said that wrong. So this would indicate that this is the direction that arrivals are landing, and then that this is the direction that departures are taking off. And so that just gives them a very high level view without having to actually read the text. And then Debbie discussed the red for the taxiway closures and the runway closures. And Debbie discussed in detail our notifications, our events that affect a large number of flights. So these are generic things that apply to multiple flights. And Debbie discussed the count lists that show the list of flights that are pushing back, actually taxiing on the runway, or the scheduled to push back. So this, and then the green is the count of arrivals that are landing on the runway. And then we also have a search feature so that when you enter search, you can search by call sign, by airline, by airport, by departure fix, or arrival fix, or if you type in the literal text GA, then it'll highlight all the general aviation flights. And while you're typing the ping, the yellow circle is drawn around each matching flight, and so that helps controllers to quickly see where a flight is located. And so, that was the complete set of features that controllers needed for situational awareness. And so I know I just blew through that, and so we can go back and ask questions as we need to a little bit further down if we have more time.
Taking a question.
Is the information exportable? Like the notification log, the notification, is that exportable or maintained, or as that gets old and is canceled, just drops off?
It stays on for the duration of a day, and then at 0800 UTC time, everything refreshes, and so it's gone for the day. So the next day we'll start out with a fresh list. So in ATD-2, everything is written to a database, and so in ATD-2, we can pull up a report of all the TMIs over a given day, but it's not anything that's directly savable from RTC itself. So customizations, and so one gentleman was asking a question last time that touched on this, and so these are the various things that we customize for the various airports. And so the departure categories of eastbound or westbound, that's the blue and the brown that you've seen in the aircraft tags, and those are defined by runway. And so in Charlotte, it's the 18 left is the eastbound, and the 18 center, 18 right would be the westbound. And similar for DFW, we kept the blue and the brown colors to be just for our own benefit in training and trying to get users accustomed to the tools. But there is absolutely no reason why you couldn't pick, pink and purple for another airport. It's completely customizable. And so, like I say here, the colors of the departure categories, instead, if you didn't want green for arrivals, you wanted something else. The cyan for advisories, any of those colors, everything, all these colors are defined in property files that we read in to define what color to use for a given airport. There is nothing in our code that is hard-coded, if DFW do this, else if Charlotte do that. Everything comes from property files or adaptation files. So time thresholds, Debbie had shown you the advisory that was 47 minutes. We have thresholds of how soon to display those advisories. So for Charlotte, they chose 60 minutes to show these strips in their advisories. You can set that value to be whatever you want to. The flight list population, when you're creating an aircraft target, how far ahead do you want to see the flights that populate your list? You don't necessarily want to see flights that are 3 days ahead. You're more concerned with today. Well, even so, are you more concerned with just the next 6 hours? So those kinds of things are customizable by airport. The flight strip orientation by gate in the Charlotte, I don't know if you noticed from Debbie's previous slides that some of the tags are cocked a little bit sideways. Well, those are oriented by how the plane would be sitting at the gate. And so that kind of position of the strip at the gate is per airport. Pushback directions, we'll show you, we'll see that a little bit later. The count list that you saw, the look ahead window, how to divide the flights, when to put the flight in the list, those are customized by airport. The data tags that you saw earlier, what the elements are in the data tag and what line they are, that's set in an adaptation file of how to configure that. Metering mode, whether or not metering is turned on and whether or not the advisories are active, that's configurable by airport. Charlotte uses metering, DFW does not. And then Debbie talked in great length about the TOBT advisories. Well, you can also show TMAT advisories instead. And so that's configurable. Runway change due to operational necessity. That's at Charlotte. The tower controllers will allow the ramp controllers to change a runway assignment if the pilot calls in and said, I need to use runway 13C because I need the extra length to get enough for my takeoff. But at DFW, they don't want the ramp controllers to make any runway changes at all. And so we have a flag to say whether or not we offer that capability to the ramp controllers or not. The definition of sectors, how much real estate does a given controller control? That's defined in adaptation. The sector frequencies, you can draw that on the map, which is very helpful for new controllers. And so whether or not do you display that, if you have a hard stand location, which they have at Charlotte, but they don't have at DFW, DFW has these drop and hold points that Charlotte does not. Spots, Charlotte has they define their spots internal in the ramp area, whereas at DFW, their spots, what they consider spots would be your actual transition point between the ramp and the taxiways. at Charlotte, they have this Mike Charlie ramp bypass where flights come into the ramp, and then if there's too much surface congestion, they exit the ramp on taxiway Mike and go down taxiway Charlie before they re-enter the ramp again. So this is something that's configurable in a property file to say whether or not you're going to offer this option. The special handling gates, when I showed you the gate statuses, the ones with the red box around it, this is defined in an adaptation file, and so in Charlotte those were gates where air start was required. And the reposition locations, north hard stand, west hard stand, cargo, whatever the list of places where you want to reposition flights, that's defined in adaptation. And then display customization. Debbie talked about the users being able to toggle various features on and off, and so the features that are displayed are customized, can be customized per airport to either offer it or not offer it. And then of course users can set their own zoom level, map rotation and so on, and save the properties, their own personal preferences to their own property files. So for surface metering, so somebody in the last session asked who's responsible for the surface metering. Now in ATD-2, it's one of our core processes that is doing the surface metering. For TBFM, I believe it's TBFM that's doing the surface metering, so, so your ramp tool would not be doing the metering itself, and so you would be gaining data from you would be getting metering advisories from TBFM, but you would not be doing the metering yourself. And that's because the metering tool is looking at all flights from all airlines and trying to get the most efficient use of the airport runway usage for the entire airport, whereas of course for your own airline you would be looking either at your own airline or you wouldn't necessarily have all the data. Excuse me. So, so you're not going to, you would not be having the tolerances for when to activate and deactivate metering. And so I don't know if TBFM's surface metering is going to be providing that. And so, yeah, sorry, TFDM, I'm sorry. And so if it doesn't have those tolerances, then when you are building your own airline tool, you need to be building in those tolerances yourself if TFDM is not providing that, so that the metering advisories are not flickering on and off, because that was very annoying for the controllers. And as Debbie spoke, the controllers want the metering to be per runway and not one metering advisory for the entire airport. And they do want to be notified when service metering is deactivated. So if metering was on for both runways, 18 left and 18 center, they would want a different notification when it's turned off for each one of them. So the flight ready times are critical for the surface metering because there's no way to get those inputs except by the user input, because there's no way for TFDM or any other system to know when the flight is ready. And so that right-click menu for the controller to enter the hold or the pushback, that's the only way to get that data. And so selecting the hold or the pushback flight sends a notification to the scheduler that the flight is ready, and so that's when the scheduler can freeze the flight time if it needs to, or if it hasn't frozen it already. And as Debbie said, the ramp controllers do want to know the expected hold times for the metered flights. We have in our implementation of the scheduler, we have what's called uncertain flights, which are flights without an EOBT, and they have a higher level of uncertainty, and so their gate advisories may fluctuate more. And so some controllers found that very irritating, and so we came up with this hashtag symbol to show instead of the time. And so the hashtag symbol would display until the flight gets close enough to its time that the scheduler is going to be sending it a fixed TOBT time based on its projected time. Is that right?
Once it is clicked, that means, pilot is ready, right?
Yeah.
And then it starts showing.
Yeah. So the pilot can click on that hashtag and that sends a message to the scheduler. The scheduler will fix its time, and then that time becomes fixed. And so whether or not to display the advisory or the hashtag, that's another one of the customizations that the controllers can choose in the map options drop-down menu. Where'd it go? This one. These are the options that the controllers can have. Let's see. So as Debbie has said, the advisories for non-TMI flights are only displayed when surface metering is enabled, but advisories for the TMI flights are always displayed even when surface metering is disabled, because since TMI flights have a controlled time of a specific time that they need to meet, the EDCT and the APREC flights, since they have a specific time, then we are always providing advisories for when those flights need to push away from the gate, or alternatively, you could say how long they'll be waiting at the gate, and so it provides an advisory for how long the flight can wait with its doors open, perhaps until it pushes off to meet its TMI time. And the ramp manager or ramp controller can exempt a non-TMI from metering or set the priority status, and this is used through our flight menu and our RTC. It's done through the flight menu, and so that way that'll send a message to the scheduler to tell it, don't meter this flight. To improve the accuracy of the scheduler, we have inputs where the user can provide additional intent information. So if they know that a flight is going to be holding for 10 minutes because they're waiting for the last of the bags to board, or they're waiting for an important connecting flight, so the RTC can add, say that this flight is going to be holding for another 10 minutes, and then that'll send a message to the scheduler, which will be reflected in a new advisory. And then updating the surface usage and flight status improves the scheduler predictions, which improves the overall runway accuracy. And so if a flight is being sent to the hard stand, or you're changing the gate or the spot or the runway, any of those features, that's going to directly impact your taxi time and the taxi predictions. And so amending that information as appropriate makes the scheduler more accurate. And then also, if somebody in the last session was asking about canceling flights, well, we have a place on our interface where you can change the status of a flight. So if you have most flights are going to be in the normal flight status, but you can suspend a flight if it's going to be, you need to take it out of service. If it's not going to be able to push back right away due to a short-term problem, say 15 to 30 minutes or something like that, but it's still going to need to use the runway soon, then you would just suspend the flight. But this option here that's grayed out is returning to gate, which is something that somebody asked about in our previous session. If the flight is leaving the gate and then has a mechanical breakdown or some other problem that it needs to return to the gate, then the ramp controller can select that option, and then that will take the flight out of the runway schedule. And then we have the option here to cancel the flight. And this is something that the controller can do if the airline hasn't done it already. So we do get messages from the airline itself if they've canceled the flight. And so this would be if the controller, if something's happening right away, or there's some failure in communication that we're not getting the message from the airline right away, this is where the controller can change the flight status. So these are some of the design principles for when we created the RTC. So judicious use of color. So we used red for stops. So Debbie had showed you the red for the departure fix closures and the APRICs without the release time. red for the airport closures from the ground stops, and the yellow for TMI alerts, just to catch attention. So we're using those colors consistently for those things, and the red also, of course, for the hold border, you know, because obviously the plane is stopped and not going anywhere theoretically while you have it on hold. We wanted to be careful to avoid too many colors and to avoid shading nuances, because then it looks like you know, a Christmas tree and you're just overwhelmed with colors, and the controllers have trouble remembering, you know, what does this color mean, what does that color mean, and then particularly for controllers that might have color issues, you don't want to be having colors that are too close in shade. You want to have them to be distinct colors without minor variances. Another important principle was consistency, and so the use of our borders around the flights, you know, we use the borders around flights and have different colors to represent different things. So we're using the same item, a border, with different colors, instead of, you know, one token for, you know, an extra token for our priority flights and a different icon for heart stand flights. You know, it gets too difficult for controllers to try and keep track of what different symbols mean. So by just having the simple border with the different colors representing different things, that's much easier for the controllers to deal with. And then the data tag fields, again, to be using the different colors of the reverse video of the different fields, the TMI fields, the APREC times, the EDCT times, and the closures, the MITs and stuff. You know, that's much more user-friendly for the controllers to be able to recognize important pieces of information, rather than if you had different icons or different looking fields. An affordance is a human factors term. It means a visual cue that offers an indication of how an object functions. And so the count boxes that were on the right-hand side of the bottom right of the RTC display that you can click on to open the count list, those are an example of an affordance. So those boxes, they look like a buttons, and so when you click on it, it behaves like a button because an action happens when you click on it. And so that's a use of the human factor affordance. Salience, that's another human factor term. It's the quality of being noticeable. So an APREC that turns red on the strip if the flight leaves the gate without an APREC time. So turning the APREC field to be red is something noticeable, and it gets the controller's attention that, you know, here's an alert that something that I need to handle. Another principle is keeping the pertinent information in focus, and so something that you'll see in another couple slides is that you can hover over the flight strip and to make it big so that you can see all the data in the full strip. And so it's not like where you have to go look over to a panel on the right side, or, you know, on the top of the field RTC window, or it's not that you have to look in another window. You know, the data is right there, bloomed under your mouse, and so it's right there in focus for you. And then alerts that need to be acknowledged use peripheral vision. So if an APREC flight does leave the gate without getting a time, that red background with the green with the black text, that begins to flash on and off, black background, red text, you know, back and forth. And so that lets the controller know that that's an important alert, and the blinking lets him know that he needs, you know, catches his attention to let him know that he needs to take action possibly. So the flight notification principles, so the proximity principle is flight strips get a notification instead of the central list to keep the information in the field of view. So like Debbie has said, when you have that notification list that lists the ground stops and MITs and stuff, those are for that and apply to a large number of flights. And so we have on the data tag itself the information that applies to that specific flight. And so that keeps the information that you need for that flight in your field of view. And then, as I just mentioned, for the APREX flights that push back without a time, here we have the notification of an EDCT time. And so when you get these EDCT times or APREC times, when the time first comes into the system, we have it flash to get the controller's attention so that he knows that that flight has an APREC time. And this is, it kind of seems like, well, that's obvious, you know, when you see a flight strip like this. But if the controller has their map zoomed out to get a wider field of view, they're not necessarily going to see that field. And so the flashing is more important when they have a zoomed out view so that they can see the field flashing and know that there's something that they need to pay attention to. Less is more when mouse clicking. So the ramp environment is fast-paced, and users don't have time to make complicated entries. You know, so this came up in the previous, session when somebody asked what gets dropped. Well, it's the mouse actions that get dropped when users get busy. And so we try to make our mouse menus to be as less work as possible. And so to reduce the workload, we have fewer mouse clicks. So we only have the menus go too deep instead of, you could get more complicated menus by going, menu, or having very long menus. And so we put the most frequently used items on top, and this particular example is that we automate handoff between sectors. And so the flight strips have an indication on it. No, that's not it. There's the field on we have on our RTC a field that shows which sector is currently managing a particular flight. And so originally the controllers in one of our earlier implementations, the controllers would manually hand off a flight to the next sector. And they like doing that because that gives them situational awareness that they're done talking to a plane, and they don't have to pay attention to it anymore, that it's going to be handled by the next controller, even though it's still in this controller's sector. But then as they got into daily use and they got too busy, doing that handoff was just too much work. And so then we started to automate the handoff between sectors we have a geographical polygon defined for each sector, and so then that would tell the controller, when the plane crosses into the next sector, then that would automatically change the notification so that controllers didn't have to do that. And Debbie had mentioned that we detect pushbacks from surveillance whenever we can. And so if the controller doesn't have time to push back execute the pushback command, then once we detect surveillance on the flight and we realize that it's a certain distance from the gate, then we'll set this flight state to push back and send that message on to the scheduler if the controller did not have time to do it. And then this is what I was mentioning previously. So you can see there that these flight strips, they only have the call sign listed, but if you bloom over the flight, then that shows all the data. And so that's just by hovering the mouse over the strip so that the controller doesn't have to click it, which gives them, it's less work giving them more data. I mean, they get more data with less work. And then our right mouse menus, we only display the options that are relevant to that particular flight in its flight state. And so here are our four flight states for departure flights, and you can see that their menus are different for each state, and they only have the options that are relevant for that flight state. And readability was a huge issue. So we had many different iterations with users to define the font style and the font size that was readable at all zoom levels. And I cannot tell you how much effort that we put into this. It was really difficult. We have another part of our readability is the horizontal versus vertical orientation. And so these are the horizontal orientation. You can see that they're wider than they are tall. There's only 3 lines of text. These are vertical. Our vertical orientation, they have 5 lines of text. And so if all these strips here at this area of the ramp were vertical, then they would tend to overlap each other. And so by having the horizontal versus vertical orientation, then that allows the controllers to see the same amount of data, but keeping it within a smaller space, so that they can still see all the data without it being overwriting each other. And then while the strip is in this strip state, they can rotate the strip to show orientation and or to keep it from overlapping another strip. And so the circle there, when you click on the flight strip, the circle appears, and so you can drag it when your mouse is inside the circle, and you rotate it. You can rotate it when the mouse is outside the circle. And that, they really like that for readability and for orientation. And then ability to drag the strip away from the gate to avoid overlap. So on the left, the blue one is overlapping the brown one a little bit, and so here the brown one has been dragged away to move it away from the blue strip so that they aren't overlapping at all. And then the ability to drag a flight tag away from the icon to avoid overlap. So here on the left, these are arrival flights and they're overlapping each other. And so here you can see that you can pull the data tag away from the icon, but you still have the leader line drawn to the icon itself to know which flight it's talking about. And you can reattach the data tag back on the icon by dragging it back over the flight icon, and then it'll reattach and continue on with the flight. Zoom. So we have 5 different levels of zoom, and this really helped with the controllers with their readability, because when you are, they like to have the zoomed out view of the map to get situational awareness of what's going on the entire surface of the airport, so that they can see if a wave of traffic is going to be coming into their sector. But if you have the big flight strips all the time, then they're overlapping each other and you can't read anything. So we have this, we iterated with the controllers multiple releases over this of the different zoom levels, and this is what they liked best. And so when you're at a far out zoom, the flight strips are just the little simple disks. And so if they need to see information, again, they just hover their mouse over it and the information will bloom if they needed to look for a specific flight. But otherwise, this gives them the complete view of everything, all the flights on the surface of the airport or a wide area of the ramp, and without a bunch of clutter. And then if you scroll in just a little bit with your mouse wheel, or you use our zoom in option that's on the map toolbar, then you get the next level of information, which is a single line of text with the call sign at the gate. You zoom in a little bit more, either with your mouse wheel or with the button on the toolbar, and you get a second zoom level, which is the 2 lines of text with a little bit more information, the destination, your aircraft type, and the fix. Then we have the 3rd zoom level of the full text. And then this bloom zoom is the full text that's independent of zoom level, and that's what's always shown when the flight is selected. And when the flight is selected, it's also shown with a little bit of a highlight so that it stands out. When you are zoomed out at these far levels, you can't see the TMI data. It becomes unreadable, and or having all that data becomes too cluttered. And so the RAM controllers wanted to be aware of important information without seeing the data all the time. So if you do have an APREC of 12:39 release time, you know, they needed to know that the flight had an APREC, but they didn't always need that time, you know, showing them in their face, you know. So they liked to have these indicators to show that yes, the flight has an APREC, or yes, the flight has a fixed closure, but without having to see the data. And so that's what these colored blocks are to do. So the controller can zoom in or bloom the strip if he wants to see what the actual time is. And so the yellow and the red blocks correspond to their corresponding TMI fields. And so like the yellow would be the APREC times, the red would be the ground stop or the APREC without a time yet. And so multiple blocks do display if appropriate. And then the white over there on the far left is if a flight has a scratch pad entry. And so sometimes the text can be really long, and so you don't want all that text displaying all the time, because then that text is overriding the tag next to it. So by having that yellow or that white block, the controller can see there's something there to look at. He can bloom the strip to see the text, and then when he's done reading it, he moves his mouth off of it and it goes back to the white block. So in our very first implementation of our RTC display, we had it on touch screens, and the controllers really liked the idea of it, and they actually liked the use of it for our previous simulations that we had with it. But as it got to go in the operational use, they decided that they didn't like it after all, and also it became a problem for us as well, and it was for these reasons. So first is the ongoing maintenance to keep the touch screens calibrated. They have to be calibrated on a regular basis, and so who's going to be doing that maintenance? You know, that became a problem. If you have a touch screen, it needs to be within arm's length, obviously. Well, the tower, the ramp controllers, you know, they're getting these larger displays so that they can see the larger screens. And so, you know, to get the whole field of view, they're having to step back, you know, so it becomes out of reach. And then if you have a large screen and you're doing these motions, this becomes very fatiguing to be touching it with the large screen like that. Your finger is not as precise as a mouse if you're trying to do a particular action, especially when you're on a zoomed out display, or some of our gentlemen controllers that had larger fingers. We had a lot of problems with them touching the wrong thing, or doing a long touch instead of a short touch, or vice versa. So it was just a lot of misrepresented actions. And then the accidental touches were hard to undo. How do you untouch? You can't. So it was hard. There was a reduced amount of functionality available. So with the finger, you have your long and short press, your swipe and your pinch. With the mouse, you have single and double click. You can drag. You've got your right mouse menu, which gives you a lot of options, and the mouse wheel, which you know, for zooming in and out and so on. And then the final thing was the Cheetos factor, was what one of our controllers called it. So, you know, if you eat your lunch and you don't wash your hands before going to work, then you get all kinds of crud on the screen, and it's just really disgusting to think of what other people have, what filth people have put on the screen. So that's why we went back to the mouses. So these are the challenges that we had creating RTC. So flight matching, we had the presentation on the fuser. You're getting data from all these different data sources, and trying to match them all together is a very difficult problem. And so we still get reports at Charlotte of mismatched flights, and it's a tough problem. Data feeds versus out the window, knowing when an in-gate arrival is parked at the gate versus towed elsewhere, knowing when to display departure at the gate versus waiting for it to be towed in from an alternate location. So the controllers want their display to match what they see out the window. But if the flight doesn't have, if an aircraft doesn't have its transponder turned on, we can't know. And so we have no way of knowing. And so that was a frustration of theirs, and so that's where we came in up with the ability to create a target and create a flight target or create an aircraft target, but controllers still have, the word in my mind is they get fussy, and that's not quite the right term, but you know, it's still a problem for them. Gate conflicts are a problem. The uncertainty of knowing when an aircraft is at the gate, either because you know, is the arrival still sitting at the gate, or has the arrival been towed away? The uncertainty in pushback times. You know, some planes can push back very quickly, whereas others take longer. You know, even though we have our averages for pushback times based on aircraft types, there is still particular flights that can still push back faster than others, and so that just creates false gate conflicts. The noise of the surveillance data around the gates, and so our planes, our surveillance, if the surveillance is noisy, then our software might think that the flight has pushed back because it's gotten a track hit a certain distance away from the gate, which is our signal that a flight has pushed back. Well, if it's just noisy surveillance, then sometimes the flight is actually still in the gate, or actually might be in a pushback but at a different location. And so that causes problems. When Charlotte first built their ramp Terminal A extension, we would get targets that would show up on terminal buildings, and so controllers would have these targets displaying on terminal buildings, which of course is physically impossible, but the surveillance was so noisy, that's where it showed the flight. There can be inaccurate or erroneous incoming data. Even though we're getting data from these data feeds, we've had many instances of wrong gate numbers that come in, you know, gate numbers that don't physically exist at the airport, or the wrong gate assigned to a flight. There are differences in company policy for their out event. You know, is it the door close event? Is it the gate release event? You know, so that changes for messages that we get from airlines of when the pushback happens. You know, if it's a door close event, they're not pushed back yet, even though their door close event is telling us they've pushed back. So that's an inconsistency. We only have gate assignments from participating airlines, so our American and Southwest currently, you know, so we don't have gate assignments directly from United, so we do get some gate information from flight stats and so on, but that is not necessarily current. And so if we get incorrect gate assignments, then that's, it's going to show up wrong on the display. Controllers had different preferences on when they wanted to see large hold advisories, and so I think we've talked about this in advance, that some controllers want to see the times an hour in advance, and some controllers don't. And so when to display an advisory is a challenge. And then this is our wish list of items. These are things that controllers have wanted us to do, but we just haven't had time to do it. So displaying tugs on the surface of the airport, you know, where are they physically located and the impact on surface metering. De-icing is a significant problem. First, displaying the de-icing pads, being able to assign flights to the de-icing stations, and then you can't meter during de-icing because you have no idea how long it's going to take flights to be in there. Diverted flights, we don't have good handling for that yet, knowing when a flight had to be diverted. Finer control on gate status. I mentioned previously that we can show a gate is blocked, but they want, or gate is closed, but they want even finer grained of blocked by another flight or blocked by a truck versus the gate being closed, and so we didn't have time to do that. We've got I've mentioned the flashing notifications, and so the ramp manager has asked to be notified if a ramp controller has not acknowledged his alert, and we haven't had time to do that. User customizable flight data tags. I showed you at the beginning, we have our data tags in the various fields. Well, that is definable per airport, but is not definable per user. And so each user would like to be able to customize what elements are on the data tags where. And they wanted to add customization to the count list, the time ranges, and have different colors based on time ranges, 5 to 15 minutes and 15 to 30 minutes, different colors and so on. Setting the strip pushback locations to match the out the window view. Adding an option to not display unowned strips. So if you're a controller and you're managing this sector, you don't even want to see the strips in the neighboring sectors if they aren't actively tracked. Being able to draw on the spot the list of flights assigned to that spot. That was a issue that we saw in our DFW human in the loop simulations. So when they push back a flight, they want to be able to assign a spot to that flight, and on the map itself, draw on the map itself, American Flight 123, American Flight 456, and so on, so that they can see what flights are going to what spots so that they can manage the flights lined up at the spots better. Providing aircraft types available for assignment to a gate. So if a gate, if a heavy aircraft cannot use a particular gate, the controllers wanted to be able to have that assignment and have some sort of flagging or some sort of look up there at the gate to be able to see that. I mentioned the scratch pad entries. Right now, if you change a scratch pad, you only see the current scratch pad entry. You don't see a history, and the controllers would like to see a history of scratch pad entries. Customization of gates that provide the air start menu option. Allowing spots to be closed. That was a thing for DFW. They like to close spots to park planes there sometimes, and so they would like to be able to have mark a spot as closed just like they mark gates as closed. And then an option to show time values in local time instead of UTC time as an airport-wide basis. By default, we do everything as UTC time, and so we don't show anything in local time, and some controllers wanted to see the local time. So that's it. Are there any questions or any comments? Yes?
Maybe this doesn't deal exactly, but you guys may still know the answer. So whether it be the RTC or this whole process, currently the ASDX system filters out the ramp. And this is supposedly a gate to the runway and a runway to the gate kind of process. Is there some kind of policy in place that makes sure that either the airport has some kind of surveillance capability all the way to the gate, i.e. a multi-lat system, or is the FAA planning to make the ASDX system not filtered into the alley so that the users can have the surface surveillance all the way to the gate?
That is an airport by airport decision, so that's not a global FAA decision. And so Charlotte is putting in better ramp surveillance that does go all the way to the gate. I don't know if you knows what the status of that is right now, but that is being...
Right. Yeah, so a Charlotte example, I mean, we have swim data for surface surveillance outside the ramp area, like active movement area from swim data. But we also have data feed from American Airlines Flight Hub inside the ramp, so that is very accurate and clean surveillance data. But I don't know on top of my head whether TFDM has a requirement for TFDM implementation airport, which may have requirement for surveillance in the ramp as well. I know they have that discussion going, but I don't know whether there is a requirement to have a ramp area surveillance.
So that is why we made the hollow icons and the flight strips to be draggable and placeable by the user, so that if the ramp surveillance is poor, they could at least move the icons to where the flight they expect it to be.
will that incorporate the data reservoir or saving data? You know, you can go back and will it be a link on like a 3-month where you can go back and replay or pull data from?
Well, we do have our database, you know, in ATD-2, we have a database that holds data quite a bit of time back. I don't know if, Bob, if you know how long.
Yeah, so well, I was reflecting, so ATD-2 does it now, but since it will become a vendor solution, is there any kind of verbiage in the like contracts where a vendor or a solution provider would be, you know, that would be part of their contract to get this, is to provide historical data?
Yeah,
I
don't think currently we have that, you know, a policy or requirements for vendors. But I guess that's something that airline probably may, want to have. Right, I think that's a really good point. Yeah. And I have 3 questions actually from the previous session that we have no time to address. So I don't know if anyone, is still in this room, but I'll just go ahead and then read the question. So last question was, is wheels up time recalculated to hold the aircraft in a pad closer to the runway if the gate is needed? So this is something, if there is a chance of gate conflict, would the scheduler see that and then, you know, push advisory earlier than initial target of block time? Answer is no, right?
No.
Yeah. So, but, you know, it's just advisory, so RAM controller can just push earlier than TOBT. It has indication of gate conflict, right, in magenta color, so he knows that.
So the scheduler is assuming that the controller is going to manage the gate conflict, you know, by whatever means he needs to meet.
Right. Yeah, and another question here is, since the airline operations is responsible for inputting EOBT, do they also update the system for delays, diverts, and maintenance? So we know that maintenance aircraft can be tagged, you know, manually, right? Like send it to the hangar or, you know, a hard stand or something like that. And then I guess delays is managed by updating EOBT. So I guess airline, if it sees, you know, some certain aircraft is being delayed because of maintenance or whatever reasons, then they can update their EOBT. So that's a way to communicate with the scheduler. Diverts, I don't think we will receive any information from airline for diversion.
Right
so
now
you
we're
mentioned
not
that
handling
in your
it. That's
slide,
one of
right?
our challenges,
Right.
is the diversions.
Yeah. And then last question was, which agency is responsible to function as surface scheduler? So I guess eventually we're migrating to TFDM. So TFDM is responsible for all this surface schedule and metering, right? So it's not really the responsibility of RAM or anything. So RAM tool, in my understanding, is just a recipient of you know, TMAT times or, you know, target or block times from TFDM and display on their display. Right?
I mentioned that also to Eric after the last meeting over at the main auditorium. Since the FAA has 51% of the vote in Charlotte, we can ask the TMC to turn departure metering on, but it is their ultimate decision. So,
Right.
we can run metering all day long, and even though it doesn't recommend it, but then they have the ability. They are the one that turns metering on and off as the TMC.
Right. So in TFDM concept of operation, I guess once, you know, the TMC wants to affirm SMP, then, or, you know, do some management, then it will send out information to participants, right, airlines, and then get their feedback. So there is some way of communicating, you know, getting feedback from airlines.
If there's no further questions.
Oh, yeah.
So I might have missed this earlier, but is there like an individual user login? I know we talked about like property files that are adjustable, so that if an individual user is logging in, you can
Right.
save those property files.
Well, he can save his personal preferences, but we don't have logins. We haven't found that necessary.
So
Um,
if someone's going in canceling flights, you have no way to run an audit of
No,
that.
no.
So as Cynthia mentioned, it's just, save the preference, file and then retrieve that, reload it, yeah.
Yeah, so this is our preference.
Mm.
I could see something like that being useful down the road in the future, because we've certainly had situations at Charlotte where we've get reports where the aircraft isn't at the gate or is showing gate conflict, or isn't showing gate conflict, and it could have certainly been from an inaction from a rank or maybe somebody not understanding it. So if there was a sign in, you can go back to that person and tell it.
Yeah, I just wanted to thank, Bernie and, Bob sitting here. So they are SME for ATD-2, and Bernie is the American Airlines representative for Charlotte Airport operations. So, yeah, we really appreciate feedback. Any other
Thank you.
questions?
Time for your break.
Thank you very
so
much.
You're welcome to ask questions, but it's time
Yeah.
for your break.
So